Okay, so as we just finished talking about, these critical points are going to be really valuable, right? If we can find where we have a critical number, it'll help us really narrow down the window when we're looking for maxima and minima. So let's practice the skill of finding critical points. So let's start with a nice simple function, a parabola, which we actually should have a visual in our head of what this looks like since the coefficient is 5, right? So I have a quadratic where the leading coefficient is positive. So I even know this thing is facing upwards. So I'm only going to have one critical point. But let's actually go through the work to find this. So I'm looking for places where the derivative is 0 or undefined. Okay, so I actually, of course, have to start by finding the derivative. So this is going to be using our skills from the first unit. So we have 10x plus 4. Now, my derivative here, this is a linear function, right? This is in y equals mx plus b form. And so I know what that looks like, and I know that that is never undefined. Never undefined. So when I'm looking for critical points, I'm not going to be able to find anywhere the derivative is undefined. I'm only going to be looking for where the derivative is 0. So let's do that. Let's solve for where is 0 equal to 10x plus 4. So I'd subtract 4 from both sides, divide by 10, and so this is going to happen at negative 2/5. Okay, so the only critical point I have is at negative 2/5. Now, does that guarantee me that negative 2/5 is an extreme value? And the answer is no. Officially, I don't know anything about this. I know actually a little bit more than that because I know that I have a parabola, but officially I just have this point, negative 2/5, comma, something on my function f, right? And this is a critical point. So if I want to take a critical value and really think of it as a critical point, a critical ordered pair, how do I figure out what the output is, right? So go back to what this function is. F of x is 5x squared plus 4x. So when x is negative 2/5, we have to evaluate 5 times negative 2/5 squared plus 4 times negative 2/5. And I know that's kind of squished. If you work that out, you get negative 4/5. So this is now what we would call a critical point, not just a critical value, right? The critical value is negative 2/5. The critical point is the ordered pair on the original function. So this is an ordered pair on the original function that has a derivative of 0. Because this is a parabola, we happen to know this is the vertex, but officially all we know so far is that it's a critical point. Okay, we'll talk more later about how we know what these things are, but for right now, it's just a critical point. Okay, now we want to determine the critical points of some new function. And this is rational. It's a little bit more complicated of functions, but of course, we're still always looking for where is f prime either 0 or undefined, right? That is the definition of a critical value, a place where the derivative is 0 or undefined. So we find the derivative, and so what I would like you to do is pause the video right now, and for practice, actually find this derivative on your own. And then simplify it a bit and see if you can get the same derivative as me. And I'm going to skip right to the answer. So we would get negative x squared plus 1 over x squared plus 1 quantity squared. Okay, so, and if you couldn't get that, then certainly go back and look at the first unit and practice your quotient rule. And then I did do a little bit of simplifying there. All right, so next up, we have to think about where is this function 0 and where is this function undefined. So this is a much more complicated function. It's not just a line. So one of the nice things is that, let's note here, this thing is a fraction, right? It has a numerator and it has a denominator. And so let's also note that where the numerator equals 0, we have something of the form 0 divided by a number. What happens when you take 0 and divide it by a number? Well, certainly you're going to get 0. So if the numerator is 0, the whole thing is 0. So where the numerator of f prime is 0, that's going to be where f prime is 0. And where the denominator is 0, so now let's think, you have some number and you're dividing it by 0, what's going to happen? Uh-oh, can't divide by 0, that's going to be undefined. So where the denominator is 0, that's going to be telling you places where f prime is undefined. So this is actually ideal. We're going to, when in doubt, we're going to try our best to I didn't mean to scribble, that was supposed to be an underline, trying to write our equation, our derivative, that function as a fraction so that we can really separate it into two separate pieces, where the numerator is 0 and where the denominator is 0. Okay, so what I'm trying to say here is if I want to find where f prime is 0, really just need to look for where is x squared plus 1. Negative x squared plus 1 going to be 0, right? The numerator. And if I want to know where f prime is undefined, I'm just going to be solving for where that denominator is equal to 0. And so I've sort of taken this problem, which is like one big problem, and I've broken it into two parts. Okay, so over here, if I want to solve this equation, I'm going to add x squared to both sides. So I get 1 equals x squared. Taking plus or minus the square root of both sides, we get two critical values, one at positive 1, one at negative 1. Over here, solving, I would square root both sides, but the square root of 0 is still 0. And then subtracting 1 from both sides, get x squared equals negative 1. Well, that doesn't happen. There's no real solution to that because no real number when you square it will give you negative 1. So we're getting no critical values where the derivative is undefined, but we have two critical values for where the derivative is 0. So writing those as critical points, I would write that as the 1 comma something and negative 1 comma something. And to get those somethings every time, I'm always going back to my original function and putting it in for x, because I'm looking for critical points on the original function f. Don't put it back into your derivative, put it back into your original function f. And if you do that, we're going to get 1/2 for 1 and negative 1/2 for negative 1. So these are our two critical points in this example. Okay, let's look at one more in this video, and then I'll pause. So again, what I'd ask you to do is, since we're finding critical points, I want us to find the derivative. I would ask you to pause the video here and go ahead and work through, hopefully your hint would be that you'd need chain rule. Work through and find the derivative of this function. I'm going to simplify this a bit. So let's see if you can see why yours would be equivalent to that. And again, if you can't figure this out, don't just, sweep it under the carpet and be done with it. So if you can't figure out how I got this from your derivative, then shoot me an email and see if, or take pictures of your work and see if we can work this out. But I want you to make sure you can get this derivative. Now, I've specifically written what would have been a negative exponent. So when you go to do chain rule, you'd have this negative exponent. I wrote it in the denominator. And I also had like a 1/3 out front, which I wrote as in the denominator as well. So I really wanted to take advantage of this tip back here, right? So if we want to try to write it as a fraction so that we can just solve where is the numerator equal to 0 and where is the denominator equal to 0. Okay, so what I mean by that is f prime will be 0 exactly when 2x minus 1 equals 0. And f prime will be undefined exactly where 3 times x squared minus x to the 2/3 equals 0, right? So we've taken this problem and broken it into two pieces. Solving where 2x minus 1 equals 0, simple algebra gets us to x equals 1/2. Down here, first thing I would do is raise both sides to the 3/2 power. Nope, I lie. The first thing I would do would divide everything by 3. Let's get rid of that. Okay, but now I would raise both sides to the 3/2 power, because 2/3 to the 3/2, that would just be to the first power. So I'm left with x squared minus x equals, and then 0 to the 3/2 is still 0. So still solving for x, I would factor out my greatest common factor, which is x, and I get a product of two numbers, and the result is 0. So I'm thinking of two numbers in my head. When I multiply them, the result is 0. So I'm taking advantage of what's called zero product property, right? And this is a unique property that's unique to 0. It's the only number that behaves this way, because if I know that x times x minus 1 is 0, that tells me that either x is 0 or x minus 1 is 0. So x equals 0 gives me one critical number. Adding 1 to both sides, I get x equals 1 is another critical number. So I have three critical numbers, one where the derivative is 0 and two where the derivative is undefined. And putting these all together as critical points, I have 1/2 comma, going back to the original function, negative 1 over the cube root of 4. That's one ordered pair. 0 comma 0 and 1 comma 0. So these are my three critical points. This first one is where the derivative is 0, and these two are where the derivative is undefined.